How do shear pins break to save your machine? Have you ever wondered how some machines manage to avoid serious damage when they encounter unexpected obstacles? The answer lies in a clever little component called a shear pin. So, how do shear pins break to save your machine? Let's break it down. Shear pins are designed as safety devices that intentionally break when a machine experiences too much force. This prevents damage to more critical and expensive parts. Think of them as sacrificial components that absorb stress and fail first under specific conditions. For instance, if a snow blower hits a rock, the shear pin will break instead of damaging the auger or motor. At the heart of this mechanism is the shear pin itself. It is a small metal rod or pin that is strategically placed in a machine's drivetrain or connection point. During normal operation, it transfers torque or mechanical force. However, when the machine encounters an abnormal load, the force can exceed the shear pin's designed strength. This is when the magic happens. When the load is too great, the shear pin shears or breaks at a predetermined stress level. This interrupts the mechanical connection and stops the machine, preventing damage to gears, shafts, motors, or other costly parts. The breaking of the shear pin is a controlled failure mode known as shear failure. This occurs when the applied force causes the material to fail along a plane parallel to the force, effectively cutting the pin. The size, material, and placement of the shear pin are carefully chosen. It needs to be strong enough to handle normal loads but weak enough to fail before causing critical damage. Practical examples of this include snow blowers, where the shear pin protects the auger from damage if it strikes an obstacle. Marine propellers also use shear pins to protect the drive shaft by braking if the propeller hits debris. In aircraft tow bars, shear pins prevent damage by braking under excessive steering or braking forces. This physically separates the tow bar from the aircraft, avoiding structural harm. By braking first, shear pins save machines from catastrophic breakdowns, reduce downtime, and lower repair costs. They are easy to replace, making them a simple but effective mechanical safeguard. This controlled failure mechanism shows how engineers design machines with intentional weak points to protect the entire system. It highlights the balance between strength and safety in mechanical design. So, the next time you see a shear pin in action, remember that it is doing its job to keep your machine safe and sound.